In this lecture, let us discuss about text classification. With increase in massive data, it becomes very difficult for the user to retrieve the required information. Also, lot of user created content is messy, unstructured, and even we can see that most of the data is nonsensical. So, from this unstructured text, extracting data is again a challenging task. So that too, here we need to analyze the grammatical structure. That is very difficult thing because text usually doesn't follow any grammatical rules. So we can get better results using models that work from bottom up. So instead of just analyzing the sentence structure and grammar, we'll just look for statistical patterns in word. So here we need to use the classification models in order to extract the meaning from the sentence. So for that, let's look at user reviews. So let us take this picture. So here, one of the most common types of online data that you might want to parse with a computer. So this is the most common data, which is here we are taking the reviews for a public park. So from this screenshot, you can see that a five-star rating was given by one person. So, but if they had posted this review without a star rating, you would still automatically understand that someone liked the park from how they described it. So, based on the text given by the user or based on the review given by the individual, you can identify rating. So, without seeing that five-star review also. So, you can say that they like the park. Then, how can we write a program that can read this text? So, this 3 lines of text and understand that a user he liked the park even though he never directly said that I like this park in the given text. So this trick is to here the trick is to reframe this complex language understanding task as a simple classification problem. So even though it was not mentioned anywhere in this sentence as I like this park, by seeing this sentence, you need to write a program in such a way that by seeing this sentence, it must be able to understand that the reviewer here, he liked the park. So for that, we are reframing this language understanding task as a simple classification problem. So let us set up a simple linear classifier that takes some words. Here the input to the classifier is the text of the review. So here we are going to provide the text as input and output is one of the 5 fixed labels, either 1 star, 2, 3, 4 or 5 stars. So here you can see this is a review text which we saw in our previous slide. So this used to be a giant parking lot where government and so on. So when you provide this review text as input to the classification model, it should give you score. So if the classifier was able to take in the text and reliably predict the correct label, it means that it must it must somehow understand the text enough to extract the overall meaning of whether or not the user or the individual like the park or not. So by seeing this sentence, how a model will identify that? So for that, first it needs to understand the text, right, to extract the overall meaning. Then only it can find out whether the reviewer liked the park or not. So, of course, the model's level of understanding is just that it churns some data through a statistical model and gets a most likely answer. So, it's not similar to human intelligence. But if the end result is same most of the time, then it doesn't really matter. So, to train our classification model, we need to collect lot of user reviews of similar places. Like it's not only about park. You need to gather reviews from similar places like business, landmarks, hotels, whatever we can find. So where the user wrote a text review and assigned a similar star rating. So you need to find out the millions of such reviews. Then we'll train the model in order to predict a star rating based on the corresponding text. So once this model is trained, then we'll use it to make predictions for the next text. So you can see that. So here you have, so just pass a new piece of text and get back the score. So we are passing another text. I hated this place as input to the classification model, and we are getting output as 1 star. So with this simplistic model, we can do all kinds of useful things. Like we could start a company that analyzes social media trends. We can even so even the companies would hire us to track how their brand is perceived online, and also to alert them of negative trends in perception. So we can, to build that, we should just scan for any tweets that mentioned our customer's business. After that, we need to feed all those tweets into the text classification model to predict if each user likes or dislikes the business. So once we have numerical ratings representing each user's feelings, then we could track changes of average score over time. So why does this work? So what can you do with text classification? So here, say suppose if you have group of emails and they are marked as spam or not spam. So usually we have seen that we have seen that we can use text classification to automatically score a user's review text. So which is nothing but it's a kind of sentiment analysis. So sentiment analysis means this is where you look at text that a user wrote and you'll try to figure out if the user is feeling positive or negative. And in the same way, you can use, you can take other practical use of text classification. So one important thing that you probably use every day as a consumer without knowing it is email spam filtering. So almost every user will be using this in their daily lives, right? So if you have a group of real mails, say suppose you have mails which are marked as spam or not spam, and here you can use uh, those in order to train a classification model. So you can even use these emails which are marked as spam or not spam in order to train the classification model. So if you take this picture, you can see input text is email text which is provided to the classification model, and the output is whether it is spam or not spam. So, along the lines of spam filtering, you can also use text classification to identify abusive or obscene content, and you can even flag it. So, a lot of websites use text classification as a first line defense against abusive users. So, by also taking the model's confidence score into consideration, you can even automatically block the worst offenders while sending the less certain cases to a human moderator to evaluate. So you can expand the idea of filtering beyond spam and abuse. Like more and more companies are using or they're making use of this text classification in order to route support tickets. So the main goal here is to parse support questions from users and route them to the right team based on the kind of issue that the user is most likely reporting. So here, based on the question, uh, that question will be passed to the corresponding team. Say if the question is like this, my mouse button isn't working when I, and so on. So that means it is somewhat related to hardware. So we need to redirect that question to hardware team. So when we pass it as input to the model, then model should identify that type of issue as a hardware failure. So by using classification to automate the busy work of supporting the tickets, the team is freed up to spend more time actually answering questions. So text classification models, they can also be used to categorize various other things. Like you can assume that anytime you post on Facebook, so when you post anything on Facebook, then it is classifying your post into various categories, like whether the post is related to family or if it is related to some event, etc. So here, this is a social media post. Check out 1,000 additional pictures of my baby. So that means it is identifying that this post is related to family related post. So that not only helps the Facebook know which content to show which to which users, but it also lets them track the topics that you are most interested in for advertising purposes. So classification is useful for sorting and labeling documents. And even imagine that your company has done thousands of consulting projects. So here, assume that your company is doing thousands of projects for clients, but your boss wants them all reorganized according to a new government project coding system. So in that case, instead of reading through every project summary document and trying to decide which project code is the best match, you could classify a random sampling of them and then build a classification model to automatically code the remaining ones. So if you take this example here, project description, so you'll provide this project description as input to the classification model. And now here the model will predict project code as output. So this is a code 0120 water treatment. So what we are doing in this case, we are not reading project summary document and trying to decide which project code is the best match. So here we are just classifying a random sampling of them. So random sampling of the project, and then we are building a classification model to automatically code the remaining ones. So these are some uses of text classification. So you just have to figure out a way to reframe the problem so that the information you're trying to extract from the text can be mapped into set of discrete output classes.